Alright, this is video 2 for the second test review on polynomials and zeros, and I'm going to cover how to do problems 5 through 7 in this one. Alright, so we're going to start off with problem 5, and here I have a list of zeros for you. And please note that it says you must write it in standard form, so that's in descending order after it's factored. Just multiply it out. So if I tell you that x has a multiplicity of 5, what we know is that it touches, the graph of this polynomial function will touch at 5 on the x-axis. So that means we start off our polynomial function with f of x always, and if our 0 is x equals 5, if our 0 is 5, then that means we need to remember to write the factor in the form x minus our root, or 0. So that means we would have x minus 5. But because the multiplicity is 2, we need to make sure our factor is squared. That's going to account for 2 of our zeros out of the 4 in this case, because we're going to have x minus 5 with multiplicity 2. That counts as 2 zeros. And then we have 1/2 and negative 3. So that's your third and fourth one. If you write x minus 1/2, you can do it that way, but you're going to have to rewrite it. And then x minus a negative 3. So if you understand what you're doing, you can go straight to this step. But remember, I taught you that if you have x minus a half, to use bottoms up and put the 2 from your denominator in that fraction up in front of x. Always do that. And of course, whenever we see minus a negative, we change that to addition. With x minus 5 being squared, we need to make sure that we understand that that's the quantity x minus 5 times itself, so that as we write it in standard form, we will get 1, 2, 3, 4 x's, which means we have x to the 4th power. This is a 4th degree polynomial function. I recommend first that you multiply these two binomials and then these two binomials. You can use box if you choose, but I will not for this video. Remember, your inner term is found by multiplying the negative 5x times negative 5x and combining. That gives you negative 10x, while negative 5 times negative 5 is positive 25. And then over here, 2x times x is 2x squared. If you want to pause and do box, like I said, that's fine. This is 6x minus x is 5x, and negative 1 times 3 is negative 3. At this point, I would recommend using the box. It just is a clean, easy way to make sure you're keeping up with all of the terms and the signs. So because it's 3 terms by 3 terms, we would have a 3 by 3 box, so 9 squares total. And now we want to fill in each square. So 2x squared times x squared is 2x to the 4th. Remember, you add exponents when multiplying like bases. 5x times x squared is 5x cubed. Negative 3 times x squared is negative 3x squared. 2x squared times negative 10x is negative 20x cubed. 5x times negative 10x is negative 50x squared. And negative 10x times negative 3 is positive 30x. 2x squared times 25 gives you 50x squared. 5x times 25 gives you 125. And then negative 3 times 25 is negative 75. So I would pause at this point and just kind of make sure that before we write out any terms and simplify, that we've actually done our multiplication correctly. Alright, I feel good about my math. So now I'll move on and combine my terms to get my final function. So my highest degree term is 2x to the 4th. I don't have another x to the 4th term. I do have 2 cubic terms, so when I combine negative 20 and add a positive 5 to it, I have negative 15x cubed. When I look at my quadratic terms, which are diagonal here, I notice that I have a 50x and a negative 50x that will zero out. So the only quadratic term I'm going to have is negative 3x squared. When I combine my linear terms here, 125x plus 30x gives me 155x. And of course my constant here, negative 75. Now, to check this work, I would definitely use the calculator. As we do with other things, we like to use y1 and y2 to check for equivalency. So I'm going to type in the factored form, x minus 5 quantity squared. And then it's okay to do x minus 1/2. Well, let's go ahead and change that up. Let's do 2x minus 1. Let's make sure we do that. And then x plus 3. Alright, next we want to type in our final function. 2x to the 4th minus 15x cubed minus 3x squared plus 155x minus 75. Let me make sure I've got that all typed in. Minus 3x squared. Alright, I feel good about it. I'm going to check my table. And voila, my y1 and y2's values match. So that tells me that my standard form is equivalent to my factored form. Another thing you can do is graph it, guys, because if you've written your factors correctly, then it should prove exactly what we were given up here. And that is that it touches at -3, it touches at 1/2, and I'm sorry, I said that wrong. It crosses at -3, it crosses at 1/2, and it touches here at +5. So that looks right. Alright, so next we'll move on to problem 6. Oh, let me just say this real quick. Make sure you have f of x in front of your function. Put a box or something around it so I can see it very clearly. Number 6. It says write the polynomial in standard form if x is equal to -3 and +4i. Well, as I taught with the complex conjugate theorem, we have to understand that every complex root has a pair. Complex roots come in pairs. So if 4i is a root, then its conjugate -4i is also a root. From here, we want to write our function in standard form, factored form. So x minus -3, x minus 4i, and x plus 4i. But of course, that minus a negative makes it x plus 3. So what I would recommend next is multiplying these two factors that have your complex zeros. As I taught you in class, the middle terms will cancel out, so I do want you to understand that you're going to get x squared plus 16. However, if you need to see that, I'll go ahead and do that at this time. I taught you how to quickly look at a complex imaginary number and its conjugate and find the standard form for those factors. But we'll have here x squared minus 4xi plus 4xi minus 16i squared. Positive 4i and negative 4xi and positive 4xi will cancel there, and negative 16. We need to remember to substitute a value of -1 for I squared, so negative 16 times -1 is positive 16. So that's why we end up with the x squared plus 16. So similar to that, if I gave you, say, 5i, and you would need to know -5i is its conjugate, and therefore when we multiplied it out, we would get x squared plus 25. If I gave you 2i and -2i, we would get x squared plus 4. So hopefully you see that 2 times 2 is 4, 5 times 5 is 25, and that we always will get a sum. Okay? Because of that, we don't have I in our polynomial anymore. We now need to multiply it with x plus 3. You can either distribute or use your box. I don't have a preference, so I'll just do your box because I know a lot of you like to do that. Get x cubed, down here 3x squared, 16x, and positive 48. So remember again to start your function with f of x, and in descending order, you have x cubed plus 3x squared plus 16x plus 48. And there really is no other way to check that other than using your home screen. So I'm going to now show you how to put a complex number in on your calculator. If you look above the decimal key, you're going to see an I. So First thing you need to do is hit mode and change your mode from real mode to a plus bi. Hopefully you recognize that as the form of a complex number. And now that means on your home screen, remember we had already stored a value for x. It really doesn't matter what we've stored for x. We're really just trying to check to see if our factored form is equivalent to our standard form. So on our home screen, we'll type in parentheses x plus 3, that quantity, times the quantity x minus 4. And again, to access the I, we need to hit the second button and then the decimal. So second I. Okay, so see how we have x minus 4i times x plus 4i. And we're going to hit enter. So we have a value of 1508. I have that because I stored a value earlier as x. You may very well get a different value. It really doesn't matter. What matters is that when I type in my standard form, I get a matching value. So I'm going to type in x cubed plus 3x squared plus 16x plus 48, and it's going to substitute the same value it used for x here. So if this is equivalent, I'll also get 1508. Now, because you may likely have a different value stored, you'll get a different number here. The point is that when you type in your factored form and standard form, they are equivalent. Okay? So that means I know my answer's right. So look at that. So far I've taught you how to make sure every answer is correct on your test. So that would be our final answer in standard form. Lastly for this video, I'm going to do problem number 7. Here I tell you that x is equal to 2 minus 3i. Your job is to remember to use its complex conjugate, 2 plus 3i, as a 0. And again, remember that we always use x minus whatever your root is. Well, what we're going to need to make sure we do is when we put in our roots that we put these in parentheses. So in factored form, we start off with f of x equals, and we use x minus, in here, 2 minus 3i. And then x minus 2 plus 3i. Always x minus your root. Now, what we need to recognize is that we're going to have to distribute this subtraction sign over both terms in our for our root. So that means we're going to have x minus 2, because a negative times a positive 2 is negative 2, and then a negative times a negative is a positive 3i. Over here, we keep our x, but a negative times a positive is a negative 2, and a negative times a positive 3i is minus 3i. Because we have 3 terms times 3 terms, I would recommend using your box. And be very cautious of any sign errors. We don't want to make sign errors because one little error makes the difference between right and wrong. So we'll fill in our box. Alright, and I'm going to pause there. I'm going to just make sure all my boxes are filled in correctly before I move on, because I don't want to make any sign mistakes. Alright, I feel confident about it. Now what should happen in this format is your I terms should always end up canceling out. If you've done your math right, it will. Negative 3xi and positive 3xi will cancel. Similarly, negative 6i and positive 6i will eliminate also. That equals 0. Now here's an I squared. It doesn't have anything to cancel, but remember that I squared is negative 1, so we're simply going to evaluate when I squared is negative 1, and we'll end up with a positive 9. This positive 9 will end up being combined with this positive 4 here. You can see we have linear terms here, so we're just about done. Our last step would be to write our function in descending order, starting with the highest degree. So I'll start here with x squared. Negative 2x minus 2x is negative 4x. All of that other stuff eliminated, but we have 9 plus 4, which is positive 13. Again, I'm going to check this on my calculator. So I'm going to use the I button, but type in factored form. So x minus parentheses 2 minus 3i, just like I have written, parentheses x minus 2 plus 3i, and hit enter, and I got 73. And now I'm going to type in x squared minus 4x plus 13. Fingers crossed it comes out to equal 73, and it does. So that tells me that my polynomial is correct. Answer in a box, and that concludes problems 5 through 7. In the next video, I'll work out problems 8 and 9.